Okay, hi. Thanks for being here. We're gonna talk a bit about interoperability between mainly hospitals and practitioners, and how at Lifen we're helping physicians and hospitals communicate about patient data. So our mission is to streamline communication, medical communication, and we're focused on fixing the sharing of medical reports between healthcare professionals. We're a Fire native since 2 or 3 years ago. We've got a few partners that are integrated with our API, Fire API. We're a team of 100 people, and we raised some money this year. We've got about just shy of 1 million reports sent by month, and we are sending those reports to around 100K practitioners per month also. So we're gonna talk a bit about the issue in France of sharing data between healthcare professionals, and then about how we solved it. We'll solve the interoperability issue with software engineering and AI, and how Fire is helping us to do that. And then just a few words on our models and a few metrics. So to start off, this is our what our product looks like. We're installing it in hospitals and also in physicians' location where they send reports or receive reports. And we want to build something like a medical mail, but smarter and obviously secure, with an up-to-date medical directory, because practitioners in France do have a secure messaging system, but the issue is that there are few hospitals that are able to connect with these messaging systems due to lack of directories or up-to-date directories, or just plain no connection with the secure messaging systems. And we wanted to be able to just plug and send. We want to be compatible with any EHR in any hospitals. And this is actually the key point, how we could do that in a world where there are a few hundred different EHRs, and we couldn't build a solution to... There's no blue button in France to just get the data in Fire structure. So yeah, a bit about the context. When you go to the hospital, you might have, actually it's mandatory for hospitals to send a discharge summary, maybe a surgical operation note, and just send it to your GP and the other physicians that follow your case. And in an ideal world, it's all the databases are in Fire, and you don't have to do extra work to send it to the physicians. Actually, in the ideal world, we don't even need to exist. The hospital can just send Fire structured data to the EHR. But obviously, in the real world, it's not like that. It gets printed, then it's sent by postal mail. The the practitioners get it. They scan it, the document, and they put it in their EHR. So it's obviously a process that's not efficient. You get data that's not searchable. It's time-consuming, and to say a bit about the scale of that, like mid-sized hospitals in France are sending like more than 1 million medical reports per year, mainly by postal mail. So there was like two interoperability issue. The first one is how to get the data out of the hospital. The second one is how to get the data into the physician EHRs that are also numerous. So as I've said, like something around 80% of French practitioners do have a secure messaging system, but in most hospitals, this addresses are used like maybe less than 10% of the time. So 90% of the time, you get this postal mail nightmare with maybe 5 to 6 days to send it to the physician. So what we did is we built a fire directory, which is updated daily. We have more than 1 million practitioners on this directory. They don't all have a secure messaging system. So if we don't have the practitioner, or if it doesn't have doesn't have a secure messaging system, we can always send it by postal mail, like before. So this is for the downstream interoperability issue, and we're going to take a look about how to get data out of the hospitals. So what is our data? We're working with medical reports. They have two main characteristics. It's two-dimensional documents. It's not like a proper sequence that we could use for our algorithm. So we've got a lot of templates. It's free-form text. Like everybody's has a different either EHR or way of writing a note. And there is a lot of domain-specific vocabulary. So what we set up was we said, okay, what's the main feature that everybody has and everybody knows how to do, and it was like printing. Every EHR in France, or every EHR has a printing feature, and so what we did, it was installing virtual printer in all the hospitals we work with, to get the PDF of what would have gone to the postal mail. We don't actually print the documents, at least not yet, but we just get by HTTPS what would have been printed. So the pros of that, it's like it's a universal solution, and also there's no training involved, because everybody at the hospitals already knows how to choose a printer and print a document. But the cons, it's highly unstructured. We just lose what might have been in the hospital EHR, and we have to restructure it with AI. So we get the PDFs, and then our task is starting. We've got to extract all the information we need to send the document to the right person. So what are these information? So first, PHIs, in order to know which patient we're talking about. So his name, date of birth, internal or external IDs. This might be like social security number, for instance. All the practitioners that are recipients. The patient might be also a recipient. With these practitioners, we just we know for those that we have in our directory, we know their preferred address to be where we can reach them. We're matching them in our directory, and then around the documents, we're extracting some info, metadata. So such as the encounter date, loading type, so was it a discharge summary, and the contents, because we want the document to be searchable afterwards. So what does the user see when we've extracted this information? Instantly after he virtually prints the documents, he or she, we present them with our predictions. and we say, okay, do you agree with that? 80% of the time, all the information is already set, and the user just validates, and the medical reports get sent by the best way we can think of. So yeah, downstream, because we've analyzed the data, and we know that we have the patient name and all the other info, the content string. We can, along with the documents, the original document, send structured metadata when applicable. All the messaging system do not support it, but when we can, we do send this structured data. Obviously, when we send postal mail, there's no way to send all the data, but we always say to the practitioners that they can log on to our app and see all the documents they've received with this data, and maybe integrate it directly to their EHRs. The reason why we're sending metadata is that a lot of EHRs are integrated with these messaging systems, and are able to read those metadata and just integrate better the documents when they're receiving it. So a few words on how FHIR is helping us to do that, or at least how we modeled it in FHIR. Our main resource is the communication request. When a user prints a document, we create a communication request, which is linked to a document reference and the binary, which is the PDF that we received. And our FHIR API is what we call hot, is in that it emits a notification for every change inside. So we'd like maybe to do that with the subscription, but it's not ready yet. And every microservice listens to all these notifications and acts upon the state of the resource. So when there's a communication request that is created, the prediction microservice, which has a few algorithms, one for each prediction, reads the communication requests, downloads the PDF, extracts all the information, infers what we are looking for, and then creates a prediction bundle. I'm going to talk about it in a few slides, and how we crammed our predictions in a FHIR world. Then when the prediction bundle is posted on our FHIR API, the other services, such as the app, gets notified that there's a new prediction, so it can show the users what did we predict, and the user validates, as I've shown in the previous slide. And after that, we consider that we have new labels for our models. So we have another microservice that handles BI and monitoring, that just flattens out the FHIR model into our data warehouse, where we can follow all of our prediction and add new labels for our models. How we're managing all this succession of microservices, we're heavily using tags on resources. Once again, we'd like maybe to use workflows in the near future, but it's not ready yet. Tags are actually working quite all right with our whole ecosystem of microservices. We have like more than 40, I think. So this is the communication request. It has been created with a few tags. The first one is that we want to treat this communication request immediately. We have like a few different SLAs, but this one is like the user wants to see the predictions immediately. And the sender is verified. In this case, we know which is the sender. Who is the sender? Okay, just a few seconds after, the prediction microservice had a look at the PDF and knows that he has to do OCR on the document because it was scanned, maybe. So it passes this information to another prediction service that can do OCR. And then the other one tells all the ecosystem just to wait for the prediction, because OCR is taking a bit more time than usual. It's processing the document. And then it gets processed at the 8th version. There's a bug on the left, but the whole process took 2 seconds and a half. So when you don't have any OCR between the time when the user clicks on print and the time where he sees the predictions, there's roughly 2 or 3 seconds. So yeah, how we stored those predictions, at first we didn't store them in the file model, because it was not meant to represent some machine learning concepts. But we tried, and this the current solution works actually quite good. So we've postulated that a set of prediction about a resource is like a bundle of the type search set. So you want to search what are the prediction about a communication request, for example, and we're sending a few resources that are our predictions. So, for instance, here we're on the bundle of prediction on a document reference, and we're looking at the document type prediction and the patient prediction. So we've actually used a standard extension on the search parameter. The standard extension is a match grade, which is used maybe when you're searching with searching algorithm, and it returns a few values. There's a value set which is possible, certain, and probable. And it's mapped really good to our way of doing prediction. With each prediction, we tell the users, okay, this prediction, we're sure of it. Don't take a particular look at if it's the right prediction. And other, we just ask the users for a stronger validation. We're using also what we called a match target, which is kind of a fire path of what is predicted in this case. So here we have 2 types of prediction on the document reference. The first one is a patient. It was the subject of the document reference. So here we're predicting an entire resource. So we can just put the resource in the bundle, but just before we're predicting a field of the document reference. So we just put the whole document reference with just the diff with our type, which is the allowing type here, surgical operation note, and always the match target that tells us, okay, we're predicting document reference dot type. Yeah, I think I've talked about that. Just a few words about what we've achieved so far and how the picture looked 2 years ago when we started to do AI, or at least heuristics to do that. We had like only a few clients, and it was easy to say, okay, for this client, the patient is always on the 3rd line, and you can find recipients. There's always one recipient. Just look for regexes and postal codes. So it worked for a few months, but obviously we had to scale up. And from these heuristics and a lot of QA, we went on to simple models that integrated our heuristics. And then, like 2 years after, we're sending the vast majority of our documents without human supervision. So we're making predictions, but they always validate all the predictions for more than 80% of the time. We're sending more than around 50K documents a day, so that's 100K prediction per day. We're serving these prediction in real time, and we've done a lot of work with the DevOps team to be able to be predictive, because we want to train our model daily or nightly, because we always have new customers and they have specific templates. We have to have, we don't have to, yeah, we have to have fresh models. And a bit of the technical part, we have 5 different deep learning models today in production, which are mainly bio-LSTMs, and for the predictions that we've talked about at the beginning. Finally, just a few words about our metrics. In 2019, we've predicted more than 4 million patients and also recipients. We've trained over 5,000 models, and it's been a great ride, and it's only the beginning of how we want to help hospitals and practitioners to structure their data and to be able to consume data in a structured way, because we always want to just not look at free-form text. So yeah, that's all for me. Yeah.
Does the patient data actually leave the hospital, and how do you deal with that? Like, for example, in Germany, I don't think you would actually be allowed to see those letters outside the hospital. Mm-hmm. How does it work in France? How does it work in your use case?
So you're saying that the patient is inside the hospitals, and how do you mean, how do we see the letters? Yeah, it's actually a good point. The letters, the reports are sent from one hospital to the practitioners, and it happens like maybe 2 weeks after the patient left the hospital, so it has to get out of the hospital. And we're working for the hospital and the recipients, so we have to store these reports for the recipient, even if the recipient doesn't have an account with us. And your question maybe is regarding how we're doing the models with this later, because we have the chance that our patient model and all our personal information are validated by our users, so that we don't have to manually do a QA on the models. Because the users just say, okay, this was a good prediction, this wasn't. So when we have to dig in internally, all the documents that are pseudonymized, and we don't access to raw medical data.
Okay. But in the file server, is it not saved there? Like, so you have
we do have a file server. It's stored not in the hospitals, but on a certified provider. It's not on our premises, obviously. It's on a certified provider, and with all the checks that you can imagine regarding control of accesses and so on.
One more question. So, is because your product essentially potentially influences therapy decision. As you predict this, are you certified as a medical product, or do you have to be, or do you not have to be?
The question is, do we have to be a certified product regarding to decision making, right? So what we're doing is mainly like meta administrative data extraction. So we're only spinning up the process of taking a document and sending it to another practitioner. We're not engaged in any kind of medical advice. We're just saying, okay, this is the document, this is the patient, this is the recipient. By the way, the recipients, they do have a secure messaging system, so do we want to send it like that? And for now, that's all. So we're not a decision-making provider for now. Yeah.
So the checking happens on the hospital side or on the practitioner side?
The hospital side. The person who wants to send the document, they print it, virtually print it, and then instantly, like 2 seconds after, they see the prediction. It's okay. It looks all right. Send it to the recipients. No other questions? Okay. Thanks.